All right, we're going to take a look at radians and degrees. And we've looked a little bit at these already, so drawing off the knowledge we know, we're going to just extend it a little further. So writing this on your paper, drawing, we're going to look at, just in general, starting with that circle that we looked at. So if we have this circle, we know that we start at 0 degrees on the x-axis there. We know that at the top we're at 90. We have 180 degrees, 270 degrees, and as we work our way around the circle, we're at 360 degrees. Now, we could also talk about this in terms of radians, and radians for what we're working on right now, we're going to use in relationship to pi. So we start with, at 0, we're at 0 pi, or we just write 0. At 180, we're at 1 pi. At 360, we're at 2 pi. So remembering that circumference equals pi times diameter, and we're going to, or 2 radius, we're going to use, we're going to kind of always go back to the fact that if our radius is 1, so if we scale the circle all the way back down, if our radius is 1, then our diameter is 2, so that means that the distance around the whole thing would be 2 pi. So then we know that 90 would be pi over 2, and 270 would be 3 pi over 2. That would be a 2. Somehow it would be written 3 pi over 2. So, all right, so as we're looking at this, we're going to talk about graphing angles and what it means to be an angle within this. Now, there's certainly other parts we could add more to this circle, but this is just one way to look at it. So here are a couple of vocab words for us. So the parts in gray, you're welcome to write, but you don't have to write. So we're always going to start with our initial side at the same place. It will always start from the origin, and then it will continue on this positive x-axis. Then the terminal side is going to be where our angle is shown, right? So this is about 120, 135 degree angle. So our terminal side is where the end of our angle essentially is going to go. And then to make sure that people are aware, we're going to put this little arrow on the inside so that people know where we're starting from and where we're ending, because there could be differences in angles, right? So just a couple quick examples before we really get into this. If we have a 90-degree angle, then we would draw that starting here and going up like that, right? But we could also have a negative 90-degree angle. So a negative 90-degree angle, we have our coordinate plane. We start with our initial side at the same place, but instead of going up, we're going to head down. So a negative 90 degrees, we're going to head this direction, okay? So just like how in integers and on our number line we have positives and negatives, we also could have, this circle, we could have it the positive direction, but we also could have it the negative direction. So something to think about. So, and talking about our terminal side and our initial side, we're going to try a couple questions with this. So first, draw an angle, this is an angle, in standard position. So, so we've got a couple examples here. 45 degrees. And negative 150. So 45 degrees, we start with our initial side on that axis, and then 45 degrees is positive, so we're going to go halfway here, and we'll show the arrow for what direction it was going in. So for negative 150, our initial side starts in the same spot. Negative 150 is close to 180, but instead of going up, we're going to go down, and it's just 30 degrees away from 180. So it's pretty close to it. And then we'll show that arrow in between that shows us what direction it's going. Okay? So what if we had this? What if we had 900 degrees? Well, 900 degrees, let's think about how many times we have 360 in 900 degrees. So 900, if I go graph this, I'm going to take away 360, and I still have some room. So I start at the same initial side, and I go around one time. Then I can take away 360 again, and I go around again, so I went around 540 already. And then what's left is 180. So all I did was I took 900 and I subtracted 360 from it. So I have to keep going, and I will end with my terminal side at 180. So the reason for the arrows on the inside is to show how many times we're circling around. So we had to go 360, another 360 is 540, and then we have 180 left. No, it's not 540, Molly. Miss Stevens. So 360 times 2, we get 720, and then we do 180 to complete that. Awesome. You guys understood what I was saying. I didn't understand it, but all right. So number 4, 2 pi over 3. Here we go. If we look at 2 pi over 3, then we're remembering where our pi and our 2 pi and everything is. So this would be 0 and 2 pi, and this would be pi. So our initial side starts at the same place. We're breaking up then the top into thirds. So we're not going to go 1/3, but we'll go 2/3 to 2 pi over 3. All right, so here are a couple more. Number 5, negative 3 pi over 2. Our initial side starts at the same place. 3 pi over 2, we know that was down here at 270, but negative, we're going to go, oh, lots of things here. Negative, we're going to go downward, so we're going to go back up to a negative 3 pi over 2, because all the way around would be 4 pi over 2, and we want it to be 3 pi over 2. So then our last one here for these types of questions, 11 pi over 3. So I want to think about how many times I'm going around in this example. So I want to take away 2 pi and see what matches with this angle, because 2 pi is going all the way around the circle. But in order to subtract, I want common denominators because I'm working with fractions. So 2 pi, if I have that equivalent to something over 3, we would have take away 6 pi over 3, right? Because 6 pi over 3 reduces to 2 pi, so I'm going to take away 2 pi, and I would end up with 5 pi over 3. Now remember that 6 pi over 3 is all the way around the circle, so 5 pi over 3, we're getting close to going around yet another time, but we're not quite there. So our initial side starts at the same place. It's positive, so we're going to start and go up. We go around one time, and then 5 pi over 3. So if I look at this, I've got a third, a third, a third, a third, right? So I'm going to go around until I get to there, okay? I'm going to erase those for us. And our final answer will look like 5 pi over 3. It'll look just over here. Good, and that's an arrow. All right, so we went around one time, and then we come back. So another way we talk about this is we use the term coterminal angles. So our next question is find two coterminal angles. So we already did this in the last part. For example, I'll come back to this page. For example, when we looked at 900 degrees, then we knew that that was the same really as 180, but we go around 2 times. So a coterminal angle is where the coterminal side of the angle ends at the same position. So 180 is a coterminal angle to 900 degrees because notice how our angle, if you take out all the stuff in the middle, it would end, the sides would both be in the same position. Similarly, number 6, pi or 5 pi over 3 is a coterminal angle to 11 pi over 3. Because if you would just draw 5 pi over 3, you would end up at the same place for the terminal angle. So what did we do with these? Both of them we either added or subtracted. In these we subtracted pi over 2 or 360 degrees. So we're going to do the same thing here. We're going to add or subtract 360. And some of you will say, you just said or subtract. Now, or is an inclusive word. It means one or the other or both. So, or could also mean and. But or is kind of universal to help us use for both of them. So, if we have 400, we're adding 360 to it. We'll end up with 400 degrees. And if we subtract 360 from it, we'll get negative 320 degrees. So that means that both of these are coterminal with 40 degrees. So if we were to graph this, just a brief sketch, then 40 degrees, we have our terminal side, 40 degrees would be about there, right? So if I'm looking at the 400 degrees, then I would have gone around 1 times 360, and then 40 more. But notice how my terminal side and my initial side are still in the same position. So that would have been my 400 degrees. In pink here, I'll put the negative 320. So negative, remember, we're going to go downwards. And then we're at 270 here, so we're at 320 there. Okay, so coterminal sides, they have the initial side and the terminal side in the same position. We use them to help us answer various questions. So number 8 here, what if we had 3 pi over 4? Well, before we were looking at adding 2 pi or subtracting 2 pi. So here, I'm going to add or subtract 2 pi. But in order to add to a fraction, I'm going to have common denominators. So I'll say 3 pi over 4 plus or minus, and then I want common denominators, so over 4. So what does 2 pi have to be? It has to be 8 pi over 4, and we'll get our answers then of 11 pi over 4 and negative 5 pi over 4. Okay, so we're adding, we add just our coefficients. So here are 2 for you. Why don't you take a moment and try these, and then we'll just put the answers up, so maybe pause it. And here are the answers. So the first one, you would have gotten 470 degrees and negative 250 degrees. And the second one, you would have gotten, or number 10, 13 pi over 6 and negative 11 pi over 6. So those would have been your answers that you should have gotten from adding 360, subtracting 360, adding 2 pi, and subtracting 2 pi. So we're just looking at all sorts of angles and things that we can do with them. So we can also convert. Now, 90 degrees, we know that 90 degrees from when we started, that converting that or looking at that in radians would be pi over 2. So using this initial circle that we have, knowing that 2 pi is the same as 360, I could use that, but I also know that pi and 180 are the same, right? That's how we can convert back and forth. It's just like if we talk about feet into inches. So, wrong one. Going back. Here we go. Number 11. Number 11, if we convert this, how we're going to do that, we want to cancel out degrees. So we will multiply by pi, and pi is equivalent to 180 degrees. So notice how our degrees will cancel. I have 90 and 180, so I can actually cancel out I can divide both top and bottom by 10. 9 divided by 18 is 1/2, so I'll end up with pi over 2. And that was what we knew to be true. So now that we've tried that, we can use that as we keep going. So let's do a couple more. Number 12, we're going to convert. So notice how the first one was in degrees, so then we wanted to convert it to radians. The next one is in radians, and radians currently are in terms of pi, so we want it to end up in degrees. So now we'll multiply, and we want to get rid of pi. So what I'm going to do is I'm going to put pi on the bottom now, and 180 degrees on the top. So I just switched which one goes where, depending on what I'm looking for in the end. Now my pi's will cancel. 180 divided by 18, you guessed it, and you get 10 degrees. So these cancel. 180 divided by 18, we end up with 10 degrees. Good, the last one is 30 degrees here. So 30 degrees, we want it to be in radians, so we'll multiply by pi over 180, because then our degrees can cancel. We also see that we have 30 and 180. Well, the zeros can cancel off as well, because I can divide both of those by 10, and then those would cancel. And 3 and 18. 3 divided by 18 we know is, good, 1/6, awesome. So you get pi over 6. That would be a 6 there on the bottom. Awesome. And let's just try one more. So what if we had 14? What if we had pi over 3? You're thinking about this, you're thinking, okay, multiply, I want to get rid of pi, so I'll put that on the bottom. 180 degrees goes on the top. Pi's cancel. I know that 18 divided by 3 is 6, so 180 divided by 3 would have to be 60 degrees. Good. Now we can always go back to converting this, but some of these you're going to get to memorize more so over time. All right, and then there's one last part of this. So we're wondering, what quadrant are we in? So we can graph these, we can do various methods, we can find coterminal angles to figure out what quadrant these would be in. Now, pi over 3, we know that from looking at the graph, that if we break it into thirds, we know this is pi. So we break this into thirds. We have pi over 3, 2 pi over 3. So this would have to be in quadrant 1. And a reminder that we usually write these in Roman numerals. So then, what if we had a question like this one? What if we had 3,142 degrees? Well, what I want to do is find my coterminal angle that's between 0 and 360. So first, I'll start and probably just divide 3,142 divided by 360. Now, if you do that as well, you'll get 8 point something. So that means I know that I'm going to go around in a circle 8 times. So using that information, I'm going to subtract 8 times 360. Because I want to figure out that coterminal angle so I can get it pretty exact, or exact to what it would be. So 8 minus 360, and I end up with 2 62 degrees. So this is a coterminal angle of this of 3,142 degrees. So I know, looking at my graph, that this is 270 degrees. So therefore, I'm really close to that, but I'm not quite at it. So I would be in quadrant 3. And we might not be given all of these in degrees. We might be given them in radians. So similarly, I would try to figure out what this is, what's the coterminal angle in radians between 0 and 2 pi. So I would take away, thinking about pi over 2. So I want to take away how many pi's over 2. So I want to take away 4 pi over 2, however many times it evenly goes into. So 4 pi over 2, 19 divided by 4 evenly would be 4, right? 4 times 4, we get 16. So I'm going to take away 4 circles that I would just be looping back around. So I would have 19 pi over 2 minus 16 pi over 2. And now this one, I would end up with 3 pi over 2. So is this even in a quadrant at all? No, this would actually be on the y-axis. So this one, if you wrote your answer more so as a picture, that would be just fine too. So showing that it's at the y-axis at that 270 mark or 3 pi over 2 mark, that would work as an answer because it's not in a quadrant. You could also say the y-axis between quadrants 3 and 4. That would work as well. So here were the notes that we've gone through before on radians and degrees. Use this as a supplement or as needed to review any of this material.